Hi guys, my name is Trevor Sullivan. In this video, we're going to explore a relatively new module from Microsoft for PowerShell called requirements. Now, if you're familiar with PowerShell desired state configuration, which is a feature that's exclusive to the Microsoft Windows platform, it's basically a service that allows you to detect different conditions on a system and then automatically remediate those conditions. So for example, let's say that you want to create a folder or a file on your file system. You can basically test to see if that folder or file exists and if it matches the contents that you expect it to. And if it doesn't, then you can automatically remediate or run a script to fix the misconfiguration on that system. Now, if you are on a non-Windows system like I am here on macOS, the PowerShell desired state configuration feature has not been ported over to PowerShell Core Edition, which is the cross-platform version of PowerShell. However, to kind of mitigate some of the missing functionality there, Microsoft has created this PowerShell module called requirements. And in my browser here, I'm just on the GitHub page under github.com/Microsoft/requirements. And this contains the current code for this particular module. Now, if we scroll down here a little bit and look at the documentation in the GitHub README, you'll see that the structure for this module is very, very straightforward. So basically, we create an array of hash tables or dictionaries, key value pairs, and they have a name, which is just some unique identifier for that particular configuration item. There's a describe step, which is kind of like a friendly description field. And then the two key parts of functionality here are going to be the test and set fields in those hash tables. Now, as you can see, the test and the set fields the values of those fields are wrapped in curly braces. And the reason that they're wrapped in curly braces is because in PowerShell syntax, curly braces indicate what's called a script block. A script block is basically the same concept as an anonymous method or a function that doesn't have a name, but is referenced by a variable, for example. So what we can do is basically specify a block of code that we want to use to test for a condition, true or false. And then based on the true or false result from that test condition, we can then execute a set method or function, or in this case, a script block, a nameless function. And that set block will be responsible for remediating whatever condition we expected to be true in the test block. So what we're going to do here is just kind of walk through how to install this module and start leveraging it on a macOS system in this place. However, this module does seem to be cross-platform, so you should be able to use it on Windows or Mac. The one thing I would call out is that requirements differs from PowerShell desired state configuration in the sense that you don't have strongly typed resources. So on these requirements objects, we just have name, describe, test, and set. That's it. We don't have like a folder path or, file permissions, properties that we can set like we might have on a DSC resource. In this case, we just have this abstract concept of a test and a set function. So just keep that in mind. The other key difference I would call out with PowerShell DSC is that DSC is capable of applying a PowerShell configuration to many systems simultaneously using remoting. However, the requirements module is more for running on a single system. So in the documentation here, if we actually look, we can see that under the comparison to DSC, we can see that it's used in a synchronous fashion versus DSC, which is asynchronous across many systems, as well as it could be useful for things like building Docker files. So if you have a bunch of dependencies that you need to define inside of a Docker file, that might be a good use case for it. Or if you're just running it on a standalone system like I am here on macOS, you can use that to install various software packages, copy files to different locations, make sure that those configuration files match the expected contents, and things like that. So just keep in mind that requirements and DSC are kind of different, but they have fundamentally similar objectives of applying configurations to systems. So let's go ahead and switch over to a terminal session here. And the first thing we need to do is, with our PowerShell environment running, we need to install the requirements module. So to do that, we'll first run the find module command, which is built into PowerShell. It basically goes out, it's very similar to like pip for Python or npm for JavaScript or Gradle and Maven. It's basically a package management utility. So what we're going to do is we're going to go out to the PowerShell gallery, PowerShellGallery.com, and we're going to search for a package named requirements. Now, once we run the find module command and actually confirm that there is a module on the PowerShell gallery named requirements, the next thing we need to do is actually install that module locally. So we'll call the install module command, specify the name of the module we want to install, and then we'll specify the scope parameter, which basically indicates to PowerShell that we want to install this module just to the current users directory, rather than installing it to a system directory that would require super user permissions to modify. So this is just going to install it to a user-specific location in my home directory. And then we'll tack on the force parameter just to make sure that we don't get any interactive prompts asking us to confirm the installation of this particular module. So as you can see, the installation of the module was very quick. It just took a couple of seconds there. And we're now ready to start exploring that module. So let's call the get module command. And as you can see from the results here, I don't currently have the requirements module imported into my PowerShell session. So if you want to explicitly import it, you can just call import module -name requirements, and you can actually use tab completion on the module name, so you don't have to type the full name requirements. I can just do req tab, and that will import the module into my environment. So now if I do a get module, you can see that the requirements module shows up now, whereas previously it did not show up in the output. So now we've imported the module into my environment, and the next thing that we typically do with PowerShell is, when we're looking at a module, we want to examine that module or inspect that module and see what commands are available inside of it. So we'll do get command module, and then requirements, we'll do tab completion there. And as you can see, there's about 6 different commands that are available inside of this module. Now, we could just go look at the README as well and basically take a look at how to utilize this module. So we can just kind of read through these steps here. We basically define an array of hash tables with the name, describe, test, and set keys. And then once we've defined those, we take that array of hash tables and just pipe it into the invoke requirement command, which is part of that requirements module. So let's go ahead and try this out. I'm going to switch over to Microsoft Visual Studio Code here. I'll hit Command N to create a new file, and then do Command K, M to switch the language mode to PowerShell. Now you can see with the little icon here in the top left that I do now have a PowerShell file. So once the proper file type is detected by Visual Studio Code, you'll get features like syntax highlighting, tab completion, or IntelliSense, whatever you'd like to call it, and a bunch of other language features. And we can actually run our PowerShell script interactively here in Visual Studio Code to make sure it's working as we expect it to. So let's go ahead and start out with a simple example. Let me bump up the font size there for you. So let's go ahead and look at the example from the README. And we'll basically just start by creating an array and then create a single hash table. And then we'll add these keys to it. And then once we add those keys with just kind of dummy values, we'll then go ahead and go back and actually fill it out. So for starters, let's create a variable called requirements, and we'll set that to an array. Now, within that array, we need to create multiple hash tables, one or more hash tables that contain the different requirements that we have for our system configuration. So for the first hash table, I'll add the name, describe, test, I'll leave that as an empty script block, and then a set. So as you can see, the requirements variable here is underlined. It's got a little squiggly underline there. And the reason is because we haven't actually referenced the requirements variable in our script yet. So the PS Script Analyzer module for PowerShell is basically telling us, hey, you defined this module this variable inside of your script, but you haven't actually used or referenced that variable anywhere inside of your script yet, so you might actually not need this variable. Well, you can ignore this because we haven't finished writing our script yet, and we will be using that variable, so you can just ignore that warning for now. So let's start by actually building out this requirement. So as an example, let's say that we wanted to have a particular folder created on our file system. So let's say I was rebuilding my Mac system and I want to make sure that there is a documents2 subdirectory within my home folder. So what I can do is just call this Trevor folder. The name that you assign to the name is not particularly relevant. It just needs to be unique within your list of requirements here. And then under the describe section, I'll say this creates the documents2 directory under my home folder. Cool. So now what we need to do is actually implement the logic of our requirement, which we do by filling out the test and the set script blocks, or anonymous functions, whatever you want to call them. So under the test, what we'll do is we'll just call the test path command, which is built into PowerShell, and then we'll specify the path parameter and specify the path to my home folder, which would be home/documents2. That's the directory that we want to exist. Now, there is a documents directory because macOS builds out that folder structure for you automatically. That's why I'm using documents2 instead of just documents. Just a contrived example. So let's actually start by commenting out the set, because you don't actually have to define the set if you don't want to. You can purely use requirements as a validation mechanism. So you can just define the test and say, do I have a true or a false result? And that's it. And that's okay. You can do that. So let's start out by doing that. And then once we test that out, we'll go back and we'll implement the set method to fix or remediate the condition that we're testing for. So now what I'll do, as per the example here in the documentation, I'm going to take that requirements variable and pipe it into the invoke requirement command. So I'm going to hit function F5 to run this on my Mac keyboard. And as you can see, we get back a couple of objects here. So we have the date, the method that was called. So again, we only defined the test. We didn't define the set method. So we can see that only the test was called here. We can see that it started and then stopped. So it's giving me kind of a log of what happened during the execution of these requirements. And you can also see the result here. So when it starts, there is no final result. But when it stops, we do get back a Boolean true or false result. And so in this case, because the documents2 directory does not exist within my macOS home directory, this is going to fail the test and we're going to get back a false result. So now what we want to do is we want to go back to the set script block. We want to implement that and cause the set block to remediate the condition so that when we call the test method, we get a true instead of a false. So let's go ahead and do that now. So within the set script block, I'll call new item, which is a PowerShell native command. And then I'll call item type, the parameter item type. I'll say, give me a directory. And then the path parameter will be home documents2. So I'll hit Control tilde to close my terminal there, just so we have a full view of the code. And so now we've implemented our set method. So all we have to do is run function F5 again to execute the entire script from start to finish. So now what you can see here is that we basically got a very similar result. So we got validate start, validate stop. And instead of getting a false, we actually got a true result this time because the test script block determined that the documents2 directory did not exist in my home folder. So what the requirements module did is it said, hey, I got a false result, so I need to call the set script block in order to remediate that condition. So this list format here is kind of hard to interpret in the log. So what I like to do personally for the requirement module is to take all that output and pipe it into the format table command. And this just turns it into a much easier to understand list of steps. So you can see when we rerun that, we're now getting this nice tabular format that shows me the test start, test stop, and the final result. And if we kill off that directory just to rerun it as if it didn't exist, I'll do another function F5 here to rerun it. You can see that this time, now that I killed off that documents2 subdirectory, I'm actually getting a little bit more output here. So I'm getting the test start and the test stop, and that returns a false. So it's basically saying the documents2 directory does not exist. So the requirements module calls the set method for that requirement. It starts, and then it stops, and it returns the path that I specified for that new directory. And then it actually goes back and it calls the test script block again to make sure that the set script block actually did correct the condition. So even though it says validate here, it's actually just calling the test method or script block that we defined again to make sure that the condition is now set to true instead of false. So we see our condition was false, we see it got corrected, and now the condition is true. So that's just very simple how to get started with the requirements module in Microsoft PowerShell Core Edition. I hope you find this video useful. This module in particular is very useful. You can get a lot more creative with this capability if you wanted to. For example, one of the things that I built here was a very simple requirement to basically make sure that the PowerShell extension for VS Code was installed. So let's actually step through that really quick. So I'll do name equals VS Code PowerShell, describe equals this installs the VS Code PowerShell extension, and then I'll implement my test block and my set block. So in my test block, what I want to do is basically say, when I run the code command, which is a shortcut for Visual Studio Code from the command line, and I do list extensions, so let's actually do that really quick. So if I run code -- help, you can see that there is a parameter called -- list extensions. And so that'll actually list out the extensions that I have installed for VS Code. So here you can see the list of extensions that I have installed. And so what we want to do is we basically want to detect if this ms-vscode.powershell extension is installed. If it's not, then let's install it. And there's actually a different parameter here called -- install extension that allows you to install the extension by its name. So what I'll do is I'll say code list extensions. I'll wrap that in parentheses so we get the output from that. And then I'll say match the name of the extension that I want to install. So let's start by commenting out the set method really quick, and then we'll just run this and see what kind of output we get. And as you can see, instead of getting a true or false, we're actually getting back the value of the extension itself. So what I can do here is say in the test method, I can say false, so Boolean false, or the same command here. And what this will do, if I do function F5 again, you'll see that instead of giving me the name of the module as the return value, it's actually giving me a Boolean true. So if it's not installed, I will get a false there. And then under the set method here, I'll go ahead and do code install extension, and then the name of the extension. So let's go ahead and test this out really quick. I'm going to navigate over to my extension list here, scroll down to the PowerShell extension here, and let me bump the size down here. I'll do uninstall, and it says, please reload VS Code to uninstall that extension. So I'll say reload window. I'll do Command-Shift-P to open the command window, and then do reload window. And as you can see, we still technically have syntax highlighting, but we don't. If I do function F5 here, you'll see that we don't get the typical behavior where PowerShell executes my script, right? And if we look at our list of installed extensions here, we no longer have the PowerShell extension installed. So if I were to take this script and fire up a new PowerShell session here, and then just paste that script in, you can see that we get a false value when we detect the VS Code PowerShell module, the VS Code PowerShell extension, and then it invokes the install command under the set here, and you can see that we now get a true value under the validate step. And so if we take a look at our list of extensions here, I don't see it in there, but if we do a reload window, you can see that the PowerShell extension has now been successfully reinstalled. So this is just to kind of show how you can use the requirements module to integrate with other applications. So if you're on Mac, you could use Homebrew, Homebrew Cask. You could use VS Code to install extensions. There's a whole bunch of different things that you could use to integrate with a requirements module. But I hope that this video was educational. If you like this video, please leave a like and leave a comment. Let me know what you thought of this video and what other kind of content you'd like to see on this channel. Thank you so much for watching, and we'll see you in the next video. Cheers.